Good morning, students. In previous class we have learned Boyle's law as well as Charles' law. Now we will discuss about Gay-Lussac law. So Gay-Lussac law can explain the relationship between the pressure and temperature. Okay. So now we will see the definition of the Gay-Lussac law. At constant volume, the pressure of a fixed mass of a gas is directly proportional to its absolute temperature. Okay. So now the mathematical representation of Gay-Lussac law is so P is directly relationship. That means P is directly proportional to the temperature, which in absolute temperature is nothing but kelvins. Okay. Pressure is directly proportional to its temperature. So in which are the constant, number of moles constant as well as volume is also constant. So this is a mathematical representation of Gay-Lussac law. If you remove in the proportionality, what happened? Some of the proportionality constant is there. That's why. So from this we can conclude that P by T equal to constant. So from this relation we can conclude that P1 by T1 equals P2 by T2. Okay. So this is a very important principle to solve the problems. P1 by T1 equals P2 by T2. Okay. So once again repeated, the definition Gay-Lussac law can explain the relationship between the pressure and temperature. At constant volume, the pressure of a fixed mass of a gas is directly proportional to its absolute temperature. Okay. So from this P by T is always constant. Graph is very important. So now here this is a graph, and in this graph these lines, so these are the straight lines because the relationship pressure is directly proportional to temperature. That's why here straight lines are obtained. So these straight lines can explain the relationship between the pressure and temperature at a constant volume. That's why these straight lines are called isochores. So iso means same, core means at constant volume. At constant volume these lines are obtained. That's why these are called isochores. So very important. In previous classes also some graphs already we have seen, which are isotherms, isobars. Now here isochores. Isotherms at constant temperature of T, isobars at constant pressure. Now isochores are at constant volume. The question is rising from here, from the graph. Write down the increasing order of the volume. Okay. So we know that you remember here lesser slope containing the greater volume. So this is the lesser slope containing the greater volume. So now the order is, first one is this one V3, because here this is a lesser slope. Lesser slope containing the greater volume. That's why increasing order of the volume is V2. Next greater than V3 is greater than V2. Next greater than V1. So this is the order. This is the increasing order of the volume. Sometimes here V1 is given, V1 is given, V2 is given, V3 is given. Now the order is V1. You find out, so which one is lesser slope? Lesser slope containing the greater volume. So this is a lesser slope. So whenever in this direction slope is increases. Okay. So you remember that slope is inversely proportional to value. Slope is inversely proportional to value. You remember that. So from this you can easily identify less slope containing the more volume. So this one is more volume and this one is less volume because higher slope containing the lesser volume. Okay, so this graphs is very important, and these straight lines are called isochores. Okay, so this is information about Gay-Lussac law. Once again repeated, Gay-Lussac law can explain the relationship between the pressure and temperature. So pressure and temperature is directly proportional to relationship. That means pressure increases, temperature is also increases. Next one is the Avogadro'S law. So Avogadro'S law can explain the relationship between the volume and number of moles or number of molecules. Okay, the definition is at constant temperature and pressure, equal volumes of all gases containing the equal number of molecules or equal number of moles. Okay, so mathematical representation of the Avogadro's law is V is directly proportional to N, and from this if you are removing the proportionality, one of the constant is there, that is K. So from this we can conclude that V by N is equal to always constant. So from this V1 by N1 is equal to V2 by N2. So this principle is used for the solving the problems. And once again repeated here, for example, you taken here, what happened here? So Avogadro's law, this is Avogadro's law. Okay, so here you will see at a temperature at constant. So which are the constant here? Sorry, here which are the constant? Temperature and pressure remain constant. Equal volume of all gases containing the equal number of molecules or moles. You will see here different, you taken different gases, oxygen gas, oxygen molecules, neon atoms and methane molecules or methane gas. Different types of gas is there. And what happened here? Temperature is 0 degrees centigrade and or 273.15 kelvins, and the pressure is 1 bar. So this situation or this conditions is called standard temperature STP conditions. We called as a STP conditions. So this is also called standard temperature and pressure. Okay, so here is also standard temperature and pressure. Oxygen containing the, how much the volume here? 22.7 liter per mole. So at the same here is also standard temperature, that means STP condition. Neon atoms containing the, how much the volume is 22.7. So here is also same as it is the methane gas. So it is a STP conditions. How much the volume occupy? Here 22.7 liter per mole. Okay, so equal volume of all gases containing the equal number of molecules. How many molecules are there here? 6.022 into 10 to the power of 23 oxygen molecules are present in how much the volume? 22 point, or we consider the, so these number of molecules occupy the this value. How much the value? 22.7 liter per mole. So from the unit is, you will also considered 1 mole of gas occupy the, how much the volume? 22.7 liters volume will be occupied. So it is also same, it is also same. So now here from this molar volume is very important. Molar volume is nothing but 1 mole of gas occupy 22.7 liters volume is called molar volume. So you remember that molar means 1 mole. So it is a 1 mole. So 1 mole gas containing the how many molecules here? 6.022 into 10 to the power of 23 molecules. So this number is also called Avogadro number. It is a very important. The question is rising from here. Define the equal value. That means define the correct value or identify the correct value of a Avogadro's number. How much the value is? 6.022 into 10 to the power of 23 particles, either atoms or molecules. So it is equal to 1 mole. And now 1 mole of gas occupy the 22.7 liters volume is called molar volume. Okay, so this is the simple and very important. So here sometimes asked the what is the Stp conditions. Which are the Stp conditions? Temperature is 0 degrees centigrade or 273.15 kelvins and the pressure is remaining the 1 bar or 10 to the power of 5 Pascal. So these conditions are called standard temperature and pressure. Next, you also remember the molar volume. So 1 mole of gas containing the 22.7 liter volume, that's why it is also called molar volume. Molar means 1 mole of molecules. 1 mole of molecules is nothing but 6.022 into 10 to the power of 23 particles. It is also called Avogadro number. So this is the information about Avogadro's law. And from this Avogadro's law, we can determine the relationship between the molar mass and density. Okay, so we know that V is equal to Kn. Now N is equal, number of moles is equal to mass by molar mass. So N value is substituted here. So what happened here? K into M by M. So now here you will see here molar mass equal to K into M by V. We know already T is equal, density is equal to M by V, mass by volume. So now here substitute M is equal to KT. So from this you removing here proportionality constant, that is the relationship. So molar mass is directly proportional to the density at constant temperature and pressure. That means molar mass of the gas increases, its density is also increases. This relationship is very important for solving the problems. So this is the information about Avogadro's law and Gay-Lussac law. Next one is very important ideal gas equation. So how to determine the ideal gas equation is next our task. Okay. So before this entering into the topic, so what is the ideal gas? Ideal gas means the gas which obey all gas laws. Which are the gas laws? Boyle's law, Charles' law, Avogadro's law. So the gas which obey all gas laws are called ideal gas. And ideal gas, from this gas laws we can determine the ideal gas equation. Okay, next, ideal gas equation describe the state of a gas, that's why it is also called state equation. So it is a one of the state. So this state, this is a gas state, so this state can explained by the ideal gas equation, that's why it is also called state equation. So ideal gas equation is a very important. We know that PV is equal to nRT. This is called ideal gas equation or state equation. So now we will see how to derive this ideal gas equation from gas laws. Okay. So these are already we know that 4 gas laws, but here we use the 3 gas laws. So which are the first one is Boyle's law. So Boyle's law can explain the volume is inversely proportional to pressure at constant temperature and mass of the gas. Okay. Next one is Charles' law can explain the relationship between the volume and temperature. Which of the relationship is directly proportional at constant N and pressure. Okay, so volume is directly proportional to temperature. And the third one is Avogadro'S law. It can explain the volume of the gas is directly proportional to number of moles or number of molecules at constant temperature and pressure. Okay, so once again repeated here, V is directly proportional to, inversely proportional to P, and V is directly proportional to temperature. Next one is P is directly proportional to number of moles or number of molecules. So from this we can conclude that V is directly proportional to NT by P. If you removing the proportionality, one of the constant is there, that is R. So from this we can conclude that so PV is equal to nRT. So here P is pressure of the gas, V is the volume of the gas, N is the number of moles, and the T is the temperature of gas. Here very important, this is called gas constant or universal gas constant. So universal gas constant containing the different values. Okay, so these are the R values. So these R values are very used for the solving the problems. So these are the values here. How much the value? If it is represented in liter atmosphere per mole per Kelvin, how much the 0.082. Next, same as this value in another units, 82.1 milliliter atmosphere per mole per Kelvin, or 0.08314 liter bar per mole per Kelvin, 0.08314 diameter cube bar per mole per Kelvin, and 8.314 Pascal meter cube per mole per Kelvin, 8.314 Newton meter per mole per Kelvin, 8.314 joule per mole per Kelvin. Next another value, another units, 8.314 kg meter square per second square per mole per Kelvin, and the 2 calorie per mole per Kelvin. These, and the next important is from the ideal gas equation. So what is that ideal gas equation now? PV is equal to nRT. So now PV by T is equal to nR. So here is also N is also constant. What happened here? N is also, that means fixed mass of the gas, we taken as a fixed mass of the gas. So total value, that means PV by T is equal to constant. So from this we can conclude that P1 V1 by T1 equals P2 V2 by T2. So this is also called combined gas law, ideal gas equation, combined ideal gas equation. So it is also very important for solving the problems. So this is a combined ideal gas equation. So from this ideal gas equation we find out the relationship between the molar mass, next density and pressure. Now we will see from the ideal gas equation. Ideal gas equation is a PV is equal to nRT. So now here interchanging the RT as well as volume. So what happened here, N by V equals P by RT. So now we know that N equal to mass by molar mass. Okay. So here N value is substituted here, M by molar mass into 1 by V equals P by RT. So M by V, we know that density, mass by volume. So from this density, molar mass equal to P by RT. So from this molar mass equal to D by P is a RT. Okay. So here, so this equation is used for very important for solving the problems. If we know the values are density and the pressure and the temperature, we find out the molar mass of a gas. Okay, it is also some expression. So from this pressure is also dRT by molar mass, and is also another, or this expression is also another expression is also, if you D density, you find out the density, what happened, that is a molar mass and pressure by RT. So this equation is also very important for solving the problems. Okay, so this is the information about ideal gas equation. This is the information about Gay-Lussac law, Avogadro's law, ideal gas equation, and the relationship between the molar mass and density. What is the relationship? Is the inversely relationship, and this is also called combined ideal gas equation, and the molar mass, density and pressure relationship. And here is also another one, molar volume is also very important. 1 mole of gas occupy the 22.7 liters volume, and 1 mole containing the how many molecules? 6.022 into 10 to the power of 23 particles, either atoms or molecules. This number is called Avogadro number. And from this different gases containing the equal volumes. So we know that equal volumes of all gases containing the equal number of molecules. So what is the condition? At standard temperature and pressure, STP conditions. STP condition means standard temperature and pressure. How much the value here? Temperature is 0 degree centigrade or 273.15 kelvins. Okay, so this is the standard temperature and pressure conditions. Thank you.